Hello and welcome to the 6.5 Notes video. This is a section about rhombi and squares. So we're continuing our study about four-sided figures or quadrilaterals, and these are very, very special quadrilaterals. So I first want to talk about a rhombus. Okay, so we have a rhombus. Okay, and I want to draw a quick, let's go ahead and just write about what a rhombus is. The unique thing about rhombi and squares is that all sides are congruent. So the first thing I'm going to say is that all four sides are congruent. Okay? And in a rhombus, the diagonals are perpendicular bisectors. Okay? And then we know that, of course, opposite sides are parallel, and we know that opposite angles are congruent as well. The other interesting thing that we know is that the diagonals are also angle bisectors. So I want to write that down here. That diagonals are angle bisectors. Okay? So let's go ahead and just draw a quick picture of a rhombus. And how I do it is I draw, if I'm just trying to draw a generic one here, I just draw a line going across, find its midpoint, and then draw another line going up and down, and try and make it as neat as possible. And then I connect my endpoints here, and here, here, and here. So the main thing that we know here, and I know it doesn't look very good, but that is that all four of these segments are congruent, okay? I also know that these segments are congruent and that these segments are congruent, and this forms a right angle here, okay? I also know that these angles are congruent here and here, and then these angles are congruent as well, okay? So we could also go in here and say that these are parallel, and that these are parallel as well. So however you want to do it. But that's what a rhombus is, okay? So that's that. So it's kind of got, the same properties as a parallelogram, except for the diagonals is what's a little bit different, okay? So the diagonals are perpendicular bisectors, and they are angle bisectors as well, okay? But then the big important thing is that all four sides are congruent. So let's talk about a square, okay? Now a square is kind of all of our special quadrilaterals all wrapped into one, okay? So a square, and you guys are very familiar with squares and rectangles. You guys see them all the time. So squares is when you have all four sides are congruent. So all four sides are congruent. All four angles are congruent, which means that they are 90 degrees. Okay, which means that they're 90 degrees. Okay. The diagonals are congruent, okay, and they're perpendicular bisectors, okay? So, let's go ahead and just draw an example of a square, and how I do it, I just draw four relatively congruent-looking shapes that meet at 90-degree angles. So all four of my angles are congruent. All four sides are congruent, and so then my diagonals here, okay, are also form a 90-degree angle in the middle, and these are also all congruent to each other. They're perpendicular bisectors. So you just got some special cases here, some special things going on. So those are the two new shapes that we're learning about. And we will talk more in depth about how to distinguish what those are. So let's go ahead and take a look at number one. It says that quadrilateral DKLM is a rhombus. Okay, so since I know it's a rhombus, it has all of these properties. Okay, all four sides are congruent, diagonals are perpendicular bisectors, opposite sides are parallel, opposite angles are congruent, and the diagonals are angle bisectors. So I'm going to come over here and just kind of label this a little bit. I know that all those sides are congruent. I know that we have a right angle here. I know that these angles are congruent here, and that these two angles are congruent as well. And then I know that these segments are congruent and these are congruent as well. So let's go ahead and take a look at what it says. It says if dk is 8, okay, so if that's 8, then what's KL? Okay, well, they're congruent because it's a rhombus, so KL is 8, okay? And then it says if DML, if the whole angle is 82, then find DKM, okay? So DML, the whole thing is 82, but DKM, that's half that length, okay? I know that this angle, first of all, angle M and K, both of these big angles, are 82, and I know that they're bisected. So if it's asking me for the little angle here, then I'm just going to call that half of 82, which is 41 degrees, okay? And then it says if angle KAL, so if KAL is 2x minus 8, then find x. Well, I know that, let's just zoom in real quick. I know that KAL is actually a 90-degree angle. Okay, because all of these angles around this intersection are 90 degrees, okay? So I'm going to set up an equation, for that. And I'm going to go ahead and just set up a simple equation of 2x minus 8 is equal to 90. Okay, so I'm going to add 8 to both sides, add 8 to both sides. And then I get 2x is equal to 98. Okay, so I'm going to divide that by 2, and that's going to end up giving me that x is 49. Okay, and that's it. That's what it wants me to find. Okay. Let's go ahead. I want you guys to try, okay, D-A-A-L, D-L, T-A. Okay, I want you guys to do 4, 5, and 6 on your own. Okay. So a little bit of algebra, but this is on your own. Make sure that you have your picture labeled, and it shouldn't be too bad, okay? So let's go ahead and let's take a look at the next couple. I'm going to do 7 and 8, and it's asking us, given each set of vertices, determine whether QRST is a rhombus, a rectangle, or a square. List all that apply, okay? So what I'm going to do here is I'm going to just go ahead and first just plot the points, and then I'm going to show you how to go about this. So I'm going to go 1, 2, 3, up 1, 2, 3, 4, 5. So here's point Q. Point R is 3, 1. S is negative 1, 1. And T is negative 1, 5, okay? So let me do this. This is Q, R, S, and T. So then I'm going to zoom in here and draw my side lengths here, here, and here. Okay, and you're probably looking at this and you're probably going, okay, yeah, this is a square because this is a 4 by 4 by 4 by 4. But it's not necessarily it's not going to always be this easy. Yeah, I know this is going to be a square. And so but what I really want to do is I want to check the diagonals, okay? I want to check the slope and distance. So I want to do this. I'm going to write this. I'm going to check the slope and distance. Slope and distance of QS. So QS has a slope of positive 1. So the slope M is equal to 1. Okay, that's the first thing I'm looking at. But the distance of Q to S, all right, and I know it's a slope of 1 because if I go from one point to the next, I go up 4 over 4. I'm going in the positive direction, so 4 over 4 is just 1. Okay, but if I'm trying to find the distance, then I want to do QS is equal to the square root of 4 squared plus 4 squared. So then I get that QS is equal to the square root of 16 plus 16. So QS is equal to the square root of 32. So I can split that up and simplify this as the square root of 16 times the square root of 2. So then QS is equal to 4 times the square root of 2. Okay? And so that's just the distance of QS. All right? Now the next thing I'm going to do is find the distance and slope between TR and see what I get. Okay? So TR, and I'm going to write that same thing over here. I'm going to say slope and distance of TR. Okay, so TR, I know that my slope is actually negative 1. And the reason why I know that is because I go down 4 and to the right 4. So because it goes in this direction, I know that it's negative, okay? And so my slopes are opposite reciprocals of each other, okay? And which is good because now I know that they're perpendicular. So because of that, I'm going to come in here and I'm going to say, all right, I know that these are perpendicular. So if my diagonals are perpendicular, then I know that I at least have a rhombus, okay? I could have a square. I need to check the distance. But the good thing is that if I wanted to check the distance of TR, okay, then I know that that's just the square root of 4 squared plus 4 squared, which we've already done the math, okay? I'm just going to go straight down to that answer right there and say that the distance of TR is 4 times the square root of 2. Okay, and so here's what I want to write, okay? The diagonals, I have a square, okay, because the diagonals are perpendicular and congruent. Okay, I'm sorry, congruent and perpendicular. Okay, so that's how I know. Okay, if the diagonals are have those properties. So I'm going to come in here and say that all 4 of these segments are congruent. Okay, so I know that we have a square. All right, let's go ahead and I'm going to do the same thing on number 8 to see what we do, and I'll have you guys do 9 and 10 on your own. So here's what I've got for number 8. Actually, I'm not going to do number 8. Those numbers go off the page. Yeah, let's do number 9. Okay, so number 9, I've got -6, -1. So 1, 2, 3, 4, 5, 6, -1. Okay, plot that point here. And then I've got 4, -6. So 1, 2, 3, 4. Down 1, 2, 3, 4, 5, 6. Plot a point there. We've got the point 2, 5. So 1, 2, 1, 2, 3, 4, 5. Okay, and then I've got -8, 10. So I've got 1, 2, 3, 4, 5, 6, 7, 8, all the way up here. Okay, so this is Q, and then R, and then S, and then T. Okay, and I'm going to zoom in and plot my lines. Not going to be perfect. Be nice if it was, but it's not. Okay. So what we're trying to figure out now is this a rhombus, a rectangle, or a square? And so, what I'm going to do is I'm going to figure out whether I'm going to check the diagonals. Okay, so I want to find the slope and distance of TS. So I want the slope, so slope and distance of TS. I'm sorry, of QS, not TS, of QS. So I'm going to come here, I'm going to actually physically draw in my diagonal there. I'm also going to draw in the right triangle that makes it, okay? And so this is a 1, 2, 3, 4, 5, 6, 7, 8. And this goes up 1, 2, 3, 4, 5, 6. So this is the slope of this, my slope is m is equal to 6 over 8, okay, which is 3/4, okay? So that's my slope. All right, now let's go ahead and do the same thing, but for TR. So I'm going to come over here. I'm going to draw in my diagonal. It's not perfect, okay? But I'm going to find the slope and distance, and I'll do the distance here in a second, of TR, okay? And so with that one, all right, I got to draw my right triangle, okay, going all the way over, all the way up, and we got to count those units. So that's 10, 11, 12, 13, 14, 15, 16. So that's 16, and then 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12. So the slope of that one, I'm going down 16 over 12, so it's actually negative 16 over 12 because it's going in this direction here, which is going to end up giving me negative 4/3, okay? So my diagonals are perpendicular. So I know that TR is perpendicular to QS, all right? So that's a good thing. All right, the next thing I need to know is are they congruent? Now, if they're congruent, then I have a square, but if they're not congruent, then I have a rhombus, okay? And the reason is because if my diagonals are perpendicular, then I know that I have either a rhombus or a square, okay? But a square has the property that my diagonals are congruent, and these aren't congruent. You can already tell, but let's actually just get a measurement real quick. Let's find the measurement of QS, which is going to be the square root of 6 squared plus 8 squared, which is going to give us the square root of 36 plus 64, which gives us the square root of, oh gosh, what is that? 100. So QS has a measure of 10, all right? So this whole length here is 10, all right? Now let's figure out the length of TR, and TR should be kind of similar. It should be 20, actually. So let's check and see. TR, that's the square root of 12 squared plus 16 squared. So that gives you the square root of 144 plus 256, which ends up giving you the square root of 400, which ends up just giving you 20. Okay, so this is 20. The other one's 10, so they're not congruent. So we have a rhombus. So TR, all right, TR is not congruent to QS, okay? Okay, that's another conclusion that we can draw. So, but we know that, what do we call it, QRST? So we know that QRST is a rhombus, okay, because the diagonals are perpendicular but not congruent. Okay, so we'll talk more about that in class, but go ahead, guys, and go ahead and do number 8 and 10. Do both of these on your own. Okay, so I hope you enjoyed this video. I had a lot of fun making it. This is a really, really fun section, and I mean that sincerely.